Right, morning once again. Apologies for that drop. Let's see if we can get cracking as far as today's revision sessions they are concerned. Right. So we've got a couple of papers here that obviously will have certain questions that are literally relevant naturally as far as the module content that has been covered, and obviously what is relevant as far as your actual exam there is concerned. So we're going to look at a couple of them, and then, like I just mentioned just before the drop there, entertain any questions that you all have associated with obviously module content and literally how to answer these questions as far as the actual module would go. I think last time we had sessions, we mentioned that your exam should be on the 2nd of July. Should there be any changes, I'm assuming that the campus will give you a heads up in terms of what's going on there. But as far as your actual PAS is concerned, it should be on the 2nd of July. Should anyone have obviously information that is different from what I have, please send something through chat there. I think we can share with the rest of the crew in terms of these particular dates there. So we're going to look at just a couple of questions there. Again, like I just mentioned right at the beginning, should you obviously have any other questions that you need reiterated, elucidated, let us know either via chat. I think later on we will obviously enable individuals to also send questions through your mic configurations there. So the first question we want to look at is the virtualization one, which is 4.3 from the 2020 past test paper there. I think we've spoken about virtualization support before, right? And we mentioned the fact that whenever you look at any type of virtualization platform, especially when you're looking at it from a computer architecture perspective, literally what you're doing is incorporating the ability to run multiple operating systems simultaneously or at the same time. And we mentioned the fact that initially there was software emulation associated with this particular type of architecture, but there were certain discrepancies, obviously, that were experienced in terms of then literally assigning hardware resources that would obviously enable that particular virtualization to function accordingly. So to alleviate some of these discrepancies that we experience within the software emulation platform, trying to obviously accommodate for virtualization, this particular feature was literally physically incorporated within your central processing units. So in order for you to actually virtualize accordingly, your CPU should literally be able to avail for this distinctive function. So in essence, with a virtualization platform, you've got a single host computer system that naturally is running specialized software to create environments that obviously replicate other computers. So it's all about replication, and I think the main thing that we've mentioned before is that obviously it's a combination of software and hardware related resources, but ultimately what you're distinctively discussing with these virtual machines is the whole concept of power saving, looking at hardware consolidation, system management, and security, and obviously looking at research at that particular point as far as your setup is concerned. So naturally, lower costs, easier disaster recovery, easier testing platforms, quicker backups, and improved productivity are all examples of what's happening in terms of the actual benefits associated with the virtualization setup. I think we've mentioned this before that, excuse me, instead of having probably 3 physical machines that you're running with obviously the different operating systems incorporated there, you can have one particular host machine with your specialized software and then load obviously the other 2 operating systems or the other 2 machines per se in that particular host. That obviously ends up saving costs or saving expenditure there, because you don't actually have to get the 3 physical machines, but you work with one, with the 2 virtual machines loaded in that environment. So obviously got a power saving and setup as well, because if you've got, for argument's sake, 3 machines that are all running at 300 watts as far as basic usage is concerned, one machine is just 300 watts. That means that if you're looking at the total of the 3 machines that you're running concurrently, you're looking at about 900 watts there as far as your energy consumption would go. But then if you're using just one machine, that consumption is cut down by about 600 watts. So obviously that's also something that you want to take into consideration in terms of what are the actual benefits associated with virtualization support there. So this particular question, they're asking what is an actual example of an environment where you would need to perform a virtualization. And again, like we've mentioned before, with this particular type of question, you will obviously want to look at a short description of what virtualization is all about. And like we mentioned before, the ability to run multiple operating systems or systems concurrently. Or alternatively, you can also mention the fact that your virtualization is all about a single host computer that is literally running specialized software, obviously creating environments that replicate other computers, like we mentioned a couple of moments ago. And then when you look at the examples now, I think last time we had sessions, we mentioned the fact that if you're looking at a scenario where you want to run multiple within a networked environment where you need multiple servers running, instead of having to buy these physical servers, you can have one host server, and then obviously have your virtualization software running on this host server to literally replicate or have a multitude of machines that are literally running at the same time. So you've got a cost saving implication in that regard. You've got a power saving implication that we mentioned literally a couple of moments ago. So in any, you can argue that you're looking at any educational setup where you want to, or with any networked environment within an educational setup, where you'll need multiple physical servers incorporated to obviously accommodate for the network functions or resources that are relevant or needed there. So to save in terms of cost implications, naturally having this virtualized environment would accommodate for that particular setup. You can also argue that some examples as well that you might want to take into consideration is the testing environment, especially for the apps. Remember, when you look at developing apps, you've got multiple platforms associated with these particular apps themselves. As typical examples, you are running these apps either on a Windows-based platform, on a Linux-based platform, or a Mac-based platform. If you're looking at it from your mobile environments, Android, and your iOS are default go-tos there. So you want to look at a scenario where instead of having physical machines that are all running these different softwares or these different operating systems, and then naturally testing the actual apps that you've developed, you typically want to obviously just have one host machine where you can have these multiple virtualized configurations incorporated there, and then you can always test your apps in that regard. So those are some of the examples that you want to look at in terms of where virtualization would be applicable, appropriate, and how it obviously would distinctively assist as far as your configurations would go. So I think one of the main things that is applicable here is that short description of what virtualization support is all about, and then given applicable examples where this particular virtualization support would function. And then you might also want to mention the whole issue of the benefits, like I was mentioning earlier on: power saving, hardware consolidation, system management and security, as well as generic research. Alternatively, you can also add in the whole concept of lowering costs, looking at easier disaster recovery and testing, quicker backups, and obviously improved productivity. These are all examples of the benefits associated with virtualization there. So for your 6 marks, short description, generic example that we've given, I think we've mentioned the whole issue of your networked environments in educational setups. We've also, and it's not limited to the educational setup. This is just an example per se, but I think at large, you're just looking at a networked environment where you might need to run multiple physical servers. And then also looking at that testing platform that I was mentioning earlier on, and then possibly then adding 1 or 2 examples or basic benefits of what virtualization support is all about, as far as that particular question there would go. All right, so that is your virtualization support typically answered in that regard. And again, I think I've mentioned this before, that some of these questions pop up as multiple choice or match column based questions. But ultimately, as you can see, as a typical example in this particular paper here, this virtualization was asked of in a scenario or long-based question. So it's always important for you to understand exactly what's happening with these concepts, because these questions can come in any particular form. So it's obviously imperative for you to understand or to literally have enough acumen there in order for you to plug in the right content in that regard. All right, so that's that one done. And then if you look at this particular question, I think we also have, or question paper rather, we also have a couple of multiple choice based questions. I think we've looked at these before. Like I always mention, just to ensure that you obviously take enough time to actually read through the question so that you understand exactly what is required of you. Some, if not all of these multiple choice based questions in certain instances have 1 or 2 statements or 1 or 2 words really that would literally change the actual output or the answer per se. That's the reason why it's very important for you to literally read through, understand exactly what is being asked of you, and then incorporate the right answer, just to avoid obviously missing out on marks there. So these can come as 1 mark questions or 2 mark questions, depending. Normally the maximum for these multiple choice based questions is 2 marks. 2 marks a piece. So again, like I mentioned before, just ensure that you read these particular questions accordingly. Take your time to do that so that at least you can incorporate the appropriate answer there. So in this particular setup, we've got this first question here that mentioned that you've got you're at a customer's workstation. Obviously, the reason being you need to install a couple of software and hardware updates. Obviously a process that would require several reboots as far as your particular computer system or this particular computer system is concerned. And naturally, if you're working with an account that or a machine that has an account that is password protected, what are you going to do? Because you've got these several reboots that are there. So normally when you look at this particular scenario, I think it also literally speaks to one of the questions I asked you to look at the conclusion of our previous session, where passwords are quite a sensitive issue when it comes to working on clients' machines or someone else's machine, if you want to look at it from a different point of view, right? Because it's all about privacy, it's all about protection of whatever is stored on that particular computer system, right? So if you're going to be working on a machine and ultimately you're rebooting them, or the machine needs to reboot just once, naturally you can ask the actual user to incorporate their password, and then we're good to go, right? But in certain instances where there are several reboots, you want to avoid a scenario where you have to always go. If it's a portable machine, it makes it slightly easier, but it's still a bit of a nuisance where you have to always go to the individual to ask them to incorporate their password. If you're working on with a desktop, obviously it becomes even more cumbersome because they actually have to come to you if they're not in immediate vicinity, right? So that becomes a bit of a nuisance in that regard. So what you want to do in certain environments like these is at least have these particular individuals temporarily change their password, or literally have you incorporate a temporal password as far as that the temporary password rather as far as that machine is concerned, so that with the multiple reboots you can always incorporate the password that you've that you've changed, and then once they're done, or once you're done with functionality as far as that particular machine is concerned, then they can always go back to incorporating whatever password was there initially, or literally changing the password again in its entirety, just for security reasons there. So what you're looking at is incorporation of a temporary password for you to function and work with the machine without discrepancies there. And then once that particular installation of these software and hardware updates is done, then that particular password can be changed again to what was there initially, or to an entirely new password. It all depends in terms of configuration that is there. So obviously A is out. Again, writing down passwords is something that you don't want to incorporate. I think we've got one other question as well. Just looking at that whole issue of writing down passwords, you want to avoid that. Not only is it ultimately rude and looking at it from an invasion of privacy point of view, but if the machine that you're working on is a mission critical machine, for argument's sake, or it has sensitive information and it becomes compromised, arguably you might be among the list of individuals that are literally culpable of this particular issue. So you want to make sure that you distance yourself from such problems that might arise. So just avoid learning other people's passwords, even if you are within the whole IT environment or department. It's something that you want to literally stay away from, because again, like I said before, if you've got a machine that's got sensitive or very critical information or data and so on, and that particular machine becomes compromised, naturally you can be an individual that can be implicated in what is happening in that regard. So try and avoid just learning people's passwords. It's one of the things you obviously don't want to do at any particular point in time. So with this particular question, C there becomes our default go-to. Ask the user to change the password temporarily for you to use, and then obviously once that is done, they can always reincorporate the password that was there initially, or ultimately change it in its entirety. And then 1.2, so that means that C there is our answer for 1.1. And then for 1.2, designed to connect, I think we've looked at this particular question before. Anything to do with your configuration in this regard is obviously going to be your high definition multimedia interface, which is HDMI. And I think it's also imperative for us to remember that with HDMI, the actual advantage is the ability to work with audio and a video simultaneously there, as far as that particular connection or cable is concerned. And then I think this particular question also in one of the previous recorded sessions, I think if I'm not mistaken, should have been the 2016 or the 2017 test revision clip that's on the channel there. Discusses the whole concept of a certain individual again that looked at installation of a new central processing unit, but obviously when the machine is booted there, nothing happens, right? The LED light for the motherboard is lit up. So obviously we in this particular regard, that's confirmation that power is obviously being appropriately supplied to your particular PCB or your motherboard. So what could be the reason there? So installation of a new CPU, I think we've discussed these before as well, where you need to take into consideration the whole concept of how you appropriately install your central processing unit. Obviously, looking at the whole concept of you incorporating the right central processing unit or the compatible CPU. Is it AMD or Intel related? We've mentioned a couple of times before that a couple of years ago, these particular CPUs were interchangeable. But these particular institutions or organizations went their separate way per se. So now if you want to use AMD, you obviously need to work with an AMD compatible board. Same difference applies with Intel. So if you look at contributions C and D there, those are naturally irrelevant because if installation of the actual central processing unit there has been successful, the whole issue of compatibility is something that has already been taken into consideration. So all we're literally saying here is that you can't fit an AMD CPU onto an Intel-based or Intel-compatible board because the sockets are different there per se. Same difference would go with an Intel CPU being incorporated on a AMD board because the socket configurations would be different and literally not compatible. So that leaves us with A, B, and E there. So we forgot to disconnect the fan. Obviously, that is out because literally, if that's literally the same thing as mentioning that you're going to be working with your central processing unit without the fan or cooling platform incorporated there. So naturally, most systems don't boot at all if the CPU fan is not literally connected, because that means that our cooling is not incorporated, and your central processing unit is bound to overheat, right, and get damaged in its entirety. So if that statement I had mentioned, he forgot to connect the CPU fan, then that's something that we can literally go with. But here I forgot to disconnect. So this is the reason why I was saying it's also very imperative for you to make sure you read these options and questions very carefully, because just removing the DIS part there of the connect statement there or word naturally can make that a correct answer. All right, so forgot to disconnect is out. It literally should be forgot to connect. All right, so that would leave us with the B and E, and then B there states, excuse me, forgot to apply thermal compound between the CPU. So this is something that could be relevant in our particular scenario. Why? Because naturally, whenever you've got cooling issues that have not been incorporated, or cooling issues associated with installation of a central processing unit, more often than not, your computer system doesn't boot at all. So here, it means that we don't have that maximum transfer of heat from the actual central processing unit to the heat sink, and then naturally having the fan dissipate that heat, right? So obviously forgot to apply thermal compound between the CPU and the heat sink, and naturally the fan assembly there becomes our default go-to as far as that particular question there is concerned. So this is all about cooling issues. And again, like I was saying earlier on, if option B was not there, just for argument's sake, and replacing disconnect with connect there automatically makes an appropriate answer as far as contributions would go. So for 1.3, our option B there becomes our default answer, and then we've got a RAM issue in 1.4. Again, a scenario-based question there. So again, like I was saying before, you'll find that most of these multiple choice questions, again, can pop up as long-based questions. So just for argument's sake, without the options that we've got there for 1.4, that can just be a generic statement that is there as far as probably section B of your exam there is concerned, long-based question, and they'll ask you to state what could be a probable cause there as far as whatever issue that they've mentioned. So again, the imperative for us to be able to identify content that is relevant in these scenario-based questions and content that isn't. So if you look at what they've got there, we've got an individual who's got a Core i7 system, right? So already, even without completing the actual a sentence or question at large. Them running an AMD CPU, them running a Core i7, an Intel Core i7 central processing unit is not relevant to the actual answer at hand, right? So regardless of whatever processes they're running, we've got a RAM issue here. So the whole concept of them either running a Core i7, Core i5, Core i9, and an AMD Ryzen, a CPU for argument's sake, has got nothing to do with why they're experiencing RAM issues in this regard, right? So he's added a new stick, bringing the total amount of RAM to literally 3 gigs. Obviously, just that's literally just for questions based, really, because or questions sake, because I think right now with the 3 gig system is a very cumbersome system there, because that is a really low amount of RAM for functionality's sake, especially with the Core i7 processor that they're mentioning there. But anyways, so within a few days, we started having random lockups and reboots, especially when doing memory-intensive tasks, such as gaming. I'm not so sure which game you can play with 3 gigs of RAM there, but right. So what is the most likely problem? Right. So naturally, when they installed this RAM, the system was working, right? But now we're experiencing certain issues when we run memory intensive applications. So what this means is we can't look at A and B, because we've already mentioned this before, that these DDRs are not backward nor forward compatible. Right? So literally, you cannot install a DDR RAM module into a DDR2 RAM slot, and the reverse is true. So the DDRs are not forward or backward compatible. That's also something that we need to take into consideration there. And then we've got this particular individual having installed RAM that did not match the speed or quality of the RAM in the system. And then we've got not the RAM that is exceeded the speed of the RAM in the actual system. So obviously D is out, because remember, when we look at your configurations there, what we're looking at, this particular machine would literally not have booted in the first place at this particular RAM literally exceeded what is compatible with the actual system itself. So that one is out, and then did not match the speed or quality of the actual RAM in the system. So in essence, that can typically be our default go-to in this regard, because we're mentioning that speed and quality, right? So it compatibility in terms of the actual type of RAM is all well and good, because we've got a successful installation, but we're only now experiencing problems when we try and run memory intensive tasks. So ultimately, technically, we're looking at a speed issue, that the speed of that particular RAM is literally not at par with the RAM that was initially there. I think the whole issue of it being 3 gigs should not derail you in this regard, because we've mentioned that literally that is massively inappropriate, but or insufficient, if you want to look at it from a different point of view. But when you're looking at it from a technical perspective, ultimately, the new RAM module that has been plugged in is obviously not at par in terms of speed and quality associated with your system at large there. So our C there becomes our default go-to as far as contributions there, options is concerned. So this particular individual's RAM did not match the speed and the quality of the RAM. So remember, if it doesn't match the speed and the quality, the system will still function without issues. You only start experiencing problems when you now need this particular RAM when you're running certain applications that obviously require more RAM as far as resource allocation there is concerned. So our C there becomes our default answer. And then I think we've discussed 1.5 a couple of times over, so I'm not going to spend time on that one. I think same difference applies as well for 1.6. We've discussed your platform controller hub or your ICH, which is in the input output controller hub, which was initially associated with naturally the South Bridge. So that one is something that we've discussed again. So 1.6, not much time on that one. And then with the power connectors, I think that we also have another recorded session of a paper that is identifying what these connectors are all about. And remember, you've got with SATA power, you've got the different connections there in terms of data and power. Normally, you find that your data is a 6-pin connector, and then your power there is a 15-pin connector. So these are default go-to there. I think if you look at it from a different perspective, we had an illustration of this in our previous sessions there. So let's see if we can, this is something that you are already familiar with, but let's see if we can literally show what's happening in this regard here. What do we have here? 2 seconds. Right, so there we have it. So this is something that you've looked at before. I think if there's again, if you look at the power supply recorded session, it discusses these particular connectors in detail. And then again, like I said before, I think there's another a revision test clip there that discusses this as well. So that's a typical example of what your SATA power connector would look like. 15 pins for power. And then if you're discussing data, that is a 6-pin connector there. So just again, if you're not too familiar with what's happening as far as your power there is concerned, you've got the power supply lecture that is there, as well as a revision a session as well. So that is that there. And then I think while we're still on that, let's just see, while we're still on that, as far as illustrations there would go, I think just to revisit what we were discussing earlier on about your virtualization, what you've got is something along these lines. All right, so with your virtualization platforms there, as we were mentioning a couple of moments right at the beginning of the session, where you've got your traditional type of architecture, which literally mimics your a physical environment. You've got your operating system that then enables you to work with whatever applications that you've got. Remember, we've mentioned a couple of times before that with the two types of softwares that are out there, your system and your application system with a subdivision of firmware and the actual operating system. We've mentioned that firmware, hard-coded software, also known as BIOS, that literally looks at a linkage between your hardware devices as well as the actual central processing unit and a computer system at large, normally incorporated by the manufacturer of the given hardware component. And we mentioned that a typical storage location for that is your ROM, right, or read-only memory configurations there. And then you've got the OS, or your operating system. I think its main purpose is to provide an interface between the user and the actual computer system at large. So you've got different types of interfaces there, your GUI, command, a line type of interface. All you're looking at here is just to literally understand the capabilities of the machine, and for the machine to understand what you literally want it to do, right? So application, on the other hand, enables you to run the machine for a specific purpose. So if you want to work with graphic design, you literally need to load graphics design application packages there. If you want to work with it as literally an entertainment center, same difference applies. But this application software can only be installed or run on top of an operating system, or on top of system software. So like we said before, every machine would literally need or literally has a system software installed, and without the system software, no machine can run accordingly. But machines can exist without application packages incorporated there. So you've got a traditional setup on your left-hand side there, and then the virtualization platform that is there on the right-hand side. So as you can see, that operating system part that is normally associated with your traditional platform has got a virtualization layer that has been installed that then enables you to run the multiple operating systems and the multiple apps that you've got incorporated there. So instead of just having one OS that is incorporated as far as your specific setup would go, we'll now have a couple of operating systems that have now been incorporated. So you now have that as an operating system, that is another operating system, that is another operating system, and obviously with the different apps that are incorporated there, as opposed to your single setup in that particular regard there. So that just extends the discussion that we were having right at the beginning as far as your a particular virtualization platform there is concerned, right? Okay, so that's that is that. So we go back to our paper. What were we discussing here? I think we're just literally discussing what's happening with your SATA power connection there. So in essence, we've got the troubleshoot. So these again is questions that we've looked at before. So you should be sorted there in terms of understanding what's happening with your troubleshoot theory. Again, with the step questions, the process questions, the theory-based questions, it's imperative for you to make sure that you incorporate the right order. All right, because the moment you add a content in there that is literally in the incorrect order, that then nullifies your contribution to that answer in its entirety. So just make sure that with these particular type of questions that deal with steps, that deal with processes, that deal with theories, it's imperative for you to remember the actual order of content there. So 1.8, 1.9 again. Okay, so 1.10. So that is content looked at before. And then if you look at question number 2, especially 2.3 there, because I think 2.4 is still just discussing that whole concept of what's happening as far as the troubleshoot theory is concerned. So here, it's part and parcel of what you did in the practical session that we had on campus a couple of weeks ago. Here, they've mentioned that installing the central processing unit, the CPU fan, and the RAM into the actual motherboard before installing the motherboard into the case helps with in different ways. So explain how this helps a PC tech when working on distinctive boards. Remember when you I think the motherboard is the motherboard rather it's one of the most intricate components as far as your actual system is concerned, both portable and your generic desktop environments. Why? Because if this particular unit malfunctions in any particular way, it literally jeopardizes the entire system or nullifies the usage of the entire system at large. I think we've discussed before the different types of errors that are associated with motherboards. Normally, you've got what they call ethereal problems, you've got or failures, you've got component failures, you've got catastrophic failures. And as far as these failures are concerned, they actually determine the proper functionality of your machine, right? So it's a sensitive component because everything it provides connectivity to everything. So it literally is the foundation of your PC, because the CPU we're talking about a couple of moments ago, the RAM we're talking about a couple of moments ago, your optical drives, your hard drives, your graphics cards, and so on. All these components can only connect or the linkage between these components is physically provided for by your motherboard. So one of the most intricate and delicate components at large, as far as your machine would go, and if not treated as such, can literally become a bit of a cumbersome process in terms of your machine there. So when you install your CPU and fan, I think most of you experienced this before, that when you're looking at installing these components while your board is within the actual case itself, it can be very difficult for you to literally reach, can be difficult for you to actually incorporate content there. So it might make more sense for you to work with these particular components while the actual motherboard is outside the case. You've got more space there. And you're literally working on a tabletop, it makes it a lot easier for you to incorporate. So literally what it does is that it makes it certain, or it kind of confirms. The first thing that you want to look at here, it kind of confirms that your CPU and your RAM actually work well with the actual motherboard itself and work well with each other. Right. So the first thing that you want to consider in this regard is that it makes certain that your CPU and your RAM work well with the actual motherboard itself, as well as each other. The second thing that you're looking at in this regard is you avoid a phenomenon called flexing. I think we talked about flexing before. Flexing is the same thing as bending, right? When you're discussing your motherboard. So when you bend your board, you risk damaging the board in its entirety. So when you're working on a tabletop, you're working on a flat surface, you're outside the case, chances of you flexing or bending the board are literally limited. So that can work appropriately, especially if you're distinctively working on that particular board when it's not within the case itself, especially when you're incorporating these components. And then the other thing that you also want to look at is that the fan assembly is literally a lot easier to install on a tabletop than within the actual the confines of a case, right? So your case can be limited in terms of space, in certain instances, whether regardless of the board actually being accommodated within that case. Remember, you've got limitations in terms of space. So normally you find that most of these heatsink and fan assemblies are quite large, and it can be a bit cumbersome when you try and fit these within we fit these particular components on the actual motherboard while the board is in the case. So those are the things you want to distinctively look at there. So first thing, literally make certain that CPU and RAM work well and literally with each other, work with the board and each other. Secondly, you want to look at avoiding or preventing flexing, which is bending the board. And then the third thing that you want to look at is obviously the fan assembly is a lot easier to install on a tabletop as opposed to within the confines of the actual case itself there. And then I think we've got another question on this one here, which is discussing the whole issue of the AC adapter. So if you look at question 3.1 there, your AC adapter is part and parcel of the power supply unit chapter in your prescribed textbooks there. And I think it's imperative for us to remember the whole concept of AC and DC. And we've mentioned before that when you're discussing AC versus DC configured architectures there, normally your power supply companies there, or your power companies would supply AC from the actual plant itself. Why? Because AC travels longer distances more efficiently, but literally almost all electrical components would require direct current as far as setups would go. So your AC adapter is obviously something that sits outside the actual computer system. So a typical example of these would be your laptop chargers or power packs, right? And but what's important there is to realize that even if it sits outside actual PC, it functions just like an internal power supply. So when you're looking at similarities there, that particular AC adapter functions exactly the same as an internal power supply unit there, because it actually looks at while it's called an AC adapter, it still converts AC to DC. All right. So regardless of it being labeled as an AC adapter, it still converts that AC that's coming from your socket to DC, so that your electrical components can work with that power accordingly. And again, like I mentioned before, it just works in the same vein as a PSU, regardless of it actually sitting outside the actual PC itself. And then if you're looking at the differences there, these adapters, AC adapters, are really interchangeable, right? In order for you to work with AC adapters, it's not just a question that, okay, this particular adapter, it looks similar to another type of adapter from a different brand machine. So it being similar, and obviously the connection being the same, this particular adapter should work across more than one machine, but it doesn't work in that regard. Why? Because you now need to consider voltage, you now need to consider amperage, you now need to also consider polarity. So these are the things that you need to take into consideration. If amperage is too low, then obviously the actual adapter won't function. The machine won't run. If polarity is reversed, this is just the same thing as you putting in the a AA battery or AAA battery in reverse when you're discussing flashlights, for instance. Remember, the flashlight won't switch on at all. So polarity is something that's important in that regard. And then also looking at if the voltage or the amperage is literally too high, you can literally toast or brick or literally damage your device in its entirety there. So that's what you need to consider when you're discussing that particular question there. The similarities, obviously, regardless of it sitting outside the actual machine itself, it still functions within the same vein as an AC adapter, as an internal power supply unit there. Why? Because it still converts AC to DC. And then obviously when you're looking at the main differences there, these particular adapters are really interchangeable. And why are they really interchangeable? And then why are they? Why is it like that? What you obviously want to consider there is the voltage, the amperage, and the polarity. They literally have to be the same in order for it to be used accordingly across the board. I think with the other CMOS-based questions, those have been tackled before. And then if you look at, which one are we looking at here? 2.3, right? If you look at 2.3 of that question that's on screen, this is literally the same question as overclocking versus underclocking. If you want to look at it from a different point of view here, because remember, when you set the jumpers, when you set the bus speed too high, rather, or too low, when it's too high, you are looking at it can literally cause system instability and damage components, because you're literally overclocking your system, setting it to higher than manufacturer set standards. And then when you set the bus speed too low, literally you can cause a lot of bottlenecks, because your machine is running at a speed that it shouldn't, or it's running at a lower speed than it should. And naturally that can cause a couple of bottlenecks there, because you don't have the appropriate speed to tackle instruction sets and what the actual system needs to do at large. So when you set it too low, you risk bottlenecks. That can still, again, cause system instability, because if you've got bottlenecks, that means that more often than not, your system is going to be freezing most of the time, or not running most of the time. You want to looking at it from a different point of view. And if you literally set it too high, naturally that can cause system instability, because they can end up damaging components. Components can end up overheating, and so on. So if you want to look at it from a silly example here, think of driving too fast in the highway versus driving too slow on the highway. I think that should give you an idea of what can happen in that regard. So just try and liken that to your computer system, and you should be good to go. All right, so that one is that for 2.3, and then 5.5 there. 5.5, I think, is something this is associated with security, right? So they've mentioned a 5-step process in this regard, right? So we've got a 5-step process here that is dealing with stopping malware spreading. So there's something you need to take into consideration in this regard. So they've given you the first one, and then they've asked you to just list the other 4. All right. So listing, again, we said that it's not you're not incorporating as much content as relevant in this regard, because you're just listing what an actual step or a stage, whichever way you look at it. So with this type of question, I think it's important to identify, again, wording, because you've got stop malware spreading, and then you've got another question within the same vein that would mention malware removal techniques. Right, so stopping malware spreading, and then malware removal techniques. I think this is imperative in this regard. So what we'll do, let's first look at malware removal techniques, and then look at stopping the malware spreading, so that you at least see where the actual differences are and where some of the similarities are as far as your specific setup is concerned. So let's see if we can quickly sort out notes in this regard. Yeah. So what we can do is right. Where's our yeah, there you go. So so you've got malware removal techniques, right? So let's see if we can populate this accordingly. So you've got so here, let's say let's call this malware removal techniques removal. So I think that's misspelled there. All right. So the first thing that you want to obviously look at is identify infected machine, right? And research on so identify and research on the actual malware that is there. So identify and research. Once you've done that, the second thing that you want to do is obviously remove the machine from your network environment more often than not. So you want to quarantine this machine, remove it entirely from the network to avoid that malware literally spreading there. And once you've done that, if you're using a Windows-based system, you want to disable what they call system restore, because you don't want the system to go back to a previous state where it was still infected by that particular malware. So you want to then disable system restore, restore. And it's imperative for you to mention that this is obviously within a Windows-based based system. All right. And then once you've done that, the fourth thing you want to then look at is remediation. All right. So remediate. And then when you're looking at remediation, the first thing that you want to then do is update your anti-malware package. All right. And then once that has been updated, you literally look at scan and remove. So you scan and incorporate removal techniques, right? So scan and removal. Okay, what's happening with our stylus again here? Scan and removal techniques there. That's your remediation process. And then the fifth thing that you want to then do is then schedule these scans. So you want to typically schedule scans, future scans, just to ensure that the system is void of any malicious software there. Remember, you can't literally be 100% safe, but you can literally push to that number. So scanning is imperative. It's also important to ensure that you always have the latest the malware updates there to try and safeguard any intrusion as far as your system would go. So again, if you're using a Windows-based system, you now want to, once this has been done, you can now enable your system restore so that you can now go back to a part where, or to a time where your machine was running without incident. So again, this is within a Windows-based system. And then lastly, what you want to then do is educate your end user. So here you want to educate end user, right? So it's to make sure that your users know what literally to do if they suspect their machine has been infected by malicious software or malware, and looking at best practices to try and just ensure that their systems are safe. So this is what you're looking at as far as removal would go. So our question now is asking about stopping this malware spreading. So here, if we're now looking at stopping malware spreading, so stopping your malware spreading here, which was literally asked of as far as a particular question would go. The first thing, so they've asked about 5 steps, right? So the first, they've already given us the first one, which is your recognize, right? Recognize. And then the second thing that you want to do in this particular instance is then quarantine, right? After you've quarantined, the third thing you want to look at is search and destroy. So this is naturally part and parcel of the scanning part, identify the malware and obviously remove it from the system. And then the fourth thing is remediate. So obviously, again, with your remediation, you've got now in this particular instance with your remediation, you're fixing what the malware has corrupted or what the malware has destroyed, right? So with remediation, it's all about fixing what the malware has distinctively corrupted. And then the fifth and last part is, again, educate your user, all right? So educate end user. Educate end user. So that's your 5 steps that they're talking about in this regard. So if you go back here, it's the recognize part that obviously they've got an issue. So as far as your particular machine there is concerned, in terms of it literally being infected with malware, and then you want to quarantine, remove it, especially when within network environments, you want to remove it from the network to work with it as isolated. Then you want to look at search and destroy. After that, you want to look at remediation purpose, functions there per se. Remember with search and destroy, you mentioned that you're actually searching for malicious code and naturally removing it in its entirety from the system at large. And then remediation is just fixing what malware has distinctively corrupted. And then lastly, educate your end user to be able to identify what's happening there. So with removal, on the other hand, if you go back to what we had mentioned there, identify and research on the actual symptoms that you're experiencing or the type of malware that might have infected your system, quarantine, disable system restore if you're working within the Windows platform. Remediate, and again with remediation in this regard is now looking at updating your anti-malware and then naturally scan and remove. and then schedule scans, obviously for regularly, to ensure that your system is literally clean, and then enable system restore if you're using a Windows-based system, and then naturally educate your user. So just be wary of that, the wording associated with those particular type of questions there. Right. If you go back, so I think that was that should have been the last question from my end. So I think we're sorted in that regard. I think there's something that came in chat here. Okay, so Happy Day is asking, what issues or problems can you face? So to be honest, I think it's more of ensuring that your actual hardware is capable of accommodating for this virtualized environment, if I understood that question correctly. So the main thing that you need to look at, I think what the main issue at large is that in order for you to run a virtualized platform, what you literally need to incorporate there is to get to understand that your system is literally capable of virtualization. Normally, you find that some particular systems come with virtualization incorporated by default or as an automatic configuration. Other systems, you need to actually activate that virtualization in BIOS. As far as your systems, they are concerned, both from a portable as well as desktop environment. So the main issue there is just ensuring that your hardware is literally capable of running virtualized environments. And normally, you want to, at least if you're looking at a basic system, you want to have at least much more than 4 gigs of RAM to accommodate for this. Obviously, by default, we've already mentioned that your as a given, your processor should be able to accommodate for this. But remember, it's not just the processor that you'll need to allocate resources from. You literally need to look at the processor, you need to look at the RAM, you also need to look at the hard drive. So whenever you're looking at virtualization platforms, your processor needs to be capable, or needs to have virtualization enabled. You need to have enough RAM, because remember, you're subdividing from your physical to your virtual environment. So your virtual setup is literally mimicking a physical machine. So if you're sitting with just for argument's sake, 4 gigs of RAM, it means you need to subdivide that 4 gigs of RAM between the host, which is the physical machine, and the actual virtual platform. So that's the reason why it's imperative for you to have at least enough RAM that can be shared across the systems to avoid bottlenecks and to actually accommodate for a smooth and fluid virtualized environment. And then obviously the hard drive as well, because these VMs would sit on these or stored on these particular hard drives. So if we don't have enough hard drive space, then that can be typically detrimental. So I think the most important thing you want to look at here is just ensuring that you've got enough hardware resources that can support the virtualization environment that you're looking at as far as your specific setup would go there. All right. I'm not so sure if that answers your question there. Please let me know if I understood your question correctly. Let me know if I've answered it correctly there. Happy there. And then we've got another one here. If your system does mean that your system is capable of supporting, yes. So by default, if your system automatically, I think one of the other types of questions also that were asked is what does 64-bit processing do for your system per se? So automatically, it means that you can run much more than 4 gigs of RAM. Remember, we've mentioned that the limitation there in terms of a 32-bit system is that you've got the totality of the amount of RAM, or the width of that particular address bus, is limited to 32 bits. And if you're looking at it from a mathematical point of view, that's 2 bits or 2 binary digits to the power 32 there. That gives you about 4.2 billion bytes that literally equate to 4 gigs, right? Or 4 gigs of RAM. So the addressable amount of RAM with a 32-bit system is limited to 4 gigs. Yes, you can physically plug in more, but you can't access anything more than that. So the 64-bit system, on the other hand, you've got a wider address bus, which then means that you can accommodate for more RAM. I think we've mentioned that on paper, you're looking at about 16 exabytes of 16 exabytes of RAM, right? I think that should translate to about 1.72 million gigs of RAM, if I'm not mistaken, and that's the massive chunk, right? And but obviously you're limited now in terms of the actual board, what the board can accommodate from an electronic point of view, and so on. But most definitely, if your system is running 64, if it's a 64-bit system, you can plug in, it can support 16 gigs of RAM. And again, I think you also need to look at it from a different point of view. Are you looking at 16 gigs in its totality, or 16 gig stick? If it's a 16 gig stick or RAM module, then you now need to look at it from a compatible motherboard perspective. But most definitely, yes, there, Heinrich, if your 64-bit system definitely would support that amount of RAM there. Right. Does that answer your question there, Heinrich? Does that answer your question? Sorted. All right. Do we have any other questions, contributions, or concerns? I think we are scheduled up until, I think we've got possibly another hour or two. So I think we can take a bit of a breather and then pop back in the next probably 15, 20 minutes. Go get your coffees, go get your fixes there, and then we can come back and then I'll leave it open for anyone who's got any questions, contributions, or concerns there, and then we'll take it from there. So I think let's take a bit of a breather, and then we'll pop back in the next 15 or 20 minutes, and then more or less have it as an open session for anyone who wants certain content revisited, and then we can take it from there. All right, so we'll see you in the, okay, that's fine there, Heinrich. We'll see you in the next 15, 20 minutes, and then we'll take it from there. Cheers for now.